Hello guys, welcome to my channel Aero Civil. From today we will start a new lecture series called Civil Capsule. In this lecture series we will discuss short tricks, short methods and basic formula which are very much important for our exam purpose. In this lecture we will talk about the short tricks by which you can remember the slope deflection formulas. Okay, so let's begin. As you can see the chart, the headings are type of beam, bending moment, end slope and deflection. Okay, so the first type of beam is cantilever beam, on which a bending moment is acting at the end of the beam. Now we have to write what is the bending moment in case of this type of condition for cantilever beam. Okay, so from this we can easily say the bending moment value should be m, because only m moment is acting, so the bending moment value is m. Now what is the end slope value? See, in case of end slope value I have a short trick for you. At first you write down that what is the bending moment value, then you write down ei by l. Okay, in denominator you write down ei by l. Okay, in this case bending moment value is m. If you write down ei by l, it is coming as m l by ei. Okay, this is the value for slope. Okay, and what is the value for deflection? M l square by 2 ei. This is the value for deflection. Now in this case it is a cantilever beam. At the end a concentrated load is acting W. So what is the bending moment value? That means W, suppose this length is L. Okay, the length of the beam is L, so the bending moment is W into L. Now write down in this way, bending moment by, here you have written 2 ei by L. In this case you have to write 2 ei by L. Okay, so it is coming, bending moment is WL and it is 2 ei by L. So at last it is coming as W L square by 2 ei. Okay, this is the formula for end slope in this condition. Now you have to write down what is the value for deflection. Okay, so the value for deflection is W L cube by 3 ei. Now in this case the bending moment value is, suppose the length is L, again we are considering, and W is the concentrated load is acting, so the bending moment value is W into L by 2, that means W L square by 2. Okay, now what we have to write? We have to write what is the end slope value. Again you can write in this way, bending moment. Here in case of 2 ei by L you have to write 3 ei by L. So here bending moment value is W L square by 2 and in denominator 3 ei by L. So it is coming W L cube by 6 ei. Okay, so this is the formula for end slope in case of this condition in cantilever beam. Now you have to write for deflection. The formula is W L to the power 4 by 8 ei. Okay, so is that clear that ei by L, 2 ei by L, 3 ei by L, gradually it is increasing. Now let us see in this case for cantilever beam a varying load is acting. Okay, now what is the formula for bending moment in case of varying load in cantilever beam? The formula is W L square by 6. Okay, now you have to write slope value. At the same way you can write m by, see up to this we have written 3 ei by L, so we have to write bending moment by 4 ei by L. Okay, here bending moment is W L square by 6 and 4 ei by L, so it is coming W L cube by 24 EI. Okay, and what is the value for deflection in this condition? W L to the power 4 by 30 EI. Okay, so it is clear for cantilever type of beam. Now we will write for simply supported beam. So in this simply supported beam, a end bending moment is acting, so the value of the bending moment is m. And what should be the value of the slope in case of this condition? The slope formula is ml by 2ei. And what is the formula for deflection in this condition? We have to write m l square whole divided by 8 ei. Okay, now in simply supported beam, a concentrated load at the center is acting. Okay, see, in every condition you just consider the length of the beam is L. Okay, so here the bending moment value is W into L by 4. Now what is the value for slope? W L square whole divided by 16 EI. Now in case of deflection, what is the formula? W L cube by 48 EI. Now in this condition, in simply supported beam, uniformly distributed load is acting. Now what is the formula for bending moment? W L square by 8, we all know. Now what is the formula for slope? For slope, the formula is W L cube by 24 EI. Now in case of deflection, what is the formula? For deflection, the formula is 5 by 384 W L to the power 4 whole divided by EI. Okay. Now the fourth case is fixed beam. Okay, in case of fixed beam, you have to write what is the slope and deflection value. Here we are not writing the bending moment value, we are just writing the slope and deflection value. In case of fixed beam, when a concentrated load is acting at the center of the beam, suppose this point is A and this point is B, so the slope value will be theta A equal to theta B equal to 0, because no slope is generating. Okay, now as the same process, when a fixed supported beam is there and the uniform distributed load is acting, so the slope will be theta A equal to theta B equal to 0. So what should be the value for deflection when a point load is acting at the center of the fixed beam? So the deflection value should be equal to W L cube whole divided by 192 EI. And when the UDL load is acting, so the formula for this should be W L to the power 4 whole divided by 384 EI. Okay, that's all for today. You just remember this formula, because this formula are very much helpful for your exam purpose. I will recommend you just remember this formula. Okay, just try to read every day this formula and remember this formula, because in your exam, when you remember this type of formula directly, so it will take less time to solve any problem. Okay, so thank you for today. Please subscribe this channel. Keep practicing.